multiple choice questions on amount of substance. Question 1, what is the mass in milligrams? So firstly, grams to milligrams, or milligrams to grams. I want to go from milligrams to grams, I divide by 1,000. Therefore, grams to milligrams, I times by 1,000. What is the mass in milligrams of carbon formed when this much of propene undergoes incomplete combustion? So I've got the moles of propene. I can see it's a 3 to 2 molar ratio. No, mass of carbon formed 2 to 6 molar ratio. AKA 1, we'll just say 2 to 6. We can simplify it to 1 to 3, but it's no point. So to find out the moles of carbon, all I'm going to do is 3.0 times by 10 to the power minus 3 times by 3, 9 times by 10 to the power minus 3, and that is the moles of carbon. And I want the mass of carbon. I know moles is mass of mR. Moles equals mass over mR. Therefore, I want mass, so mass is moles times by mR. So the mass in grams is going to be 9 times by 10 to the power minus 3 times by the mR of carbon, which is 12. 9 times by 10 to the power minus 3 times by the mR of carbon, 12. But that's in grams, and I want it in milligrams. So I get 0.108 grams, but I want it in milligrams, so I need it times by 1,000. So 1, 2, 3, 108 milligrams, which is C. Perfect. Question 2. The removal of silicon dioxide with limestone can be represented by the following equation. Minimum mass of calcium carbonate need to remove this much silicon dioxide. First time I looked at it, I was like, is that even enough information to find that out? And it is. We just need to keep rearranging using moles equals mass over mR. The mass of silicon dioxide is 1,000 kilograms, 0.23 divided by the mR. And that is the moles of silicon dioxide. But because of 1:1 molar ratio, that's also the moles of calcium carbonate. So therefore, to find the minimum mass of calcium carbonate, moles of mass of mR mass is going to be the moles, which I've already got stored in my calculator, times by the mR of calcium carbonate, which is times by the mR of calcium carbonate. Calcium, Ca 40.1 plus copper 12 plus 16 plus 16 plus 16. And I get a ridiculously large number, but that's the mass in grams. I want the mass in tons. So to go from grams to kilograms, I need to divide by 1,000. And then to go from kilograms to tons, I need to divide by 1,000 again. So I need to do my answer times by 10 to the power minus 6 divided by a million. And I get 1.67. Therefore the answer is C. Then question 3. Silver oxide can be reduced by passing hydrogen gas over the heat oxide. The maximum mass of silver that could be obtained from this much of silver oxide is. Well, first thing I need to do, that's the mR of it. That's the formula of it. So I need to find out the moles of it. The moles is the mass 2.32 of silver oxide divided by Ag2. While Ag has an mR of silver, which is can't really find in the periodic table. Obviously it should be here 107.9 plus 107.9 plus 16 from the oxygen. So it's going to be 2.32 divided by 107.9 plus plus 107.9 plus 16. That's the moles of silver oxide. I want to find out the maximum mass of silver. They're both going to have a 1-to-1 molar ratio. So therefore, find out the mass, moles and mass of MR. Mass is going to be the moles that I just worked out, 1-to-1 molar ratio, times by the MR of silver. Well, silver is just Ag, and the MR of that is 107.9. So my answer times by 107.9. Why? And I get 1.08 grams, the maximum mass of silver. But because we've got 2 silver atoms, I need to times my answer by 2. That's the only logical thing I could see, and therefore I get 2.16 grams. And that's the end of multiple choice questions.